Let's solve this identity step by step. We need to prove that the numerator sine 7x plus sine 5x plus sine 9x plus sine 3x divided by the denominator cos 7x plus cos 5x plus cos 9x plus cos 3x is equal to tan 6x. At first glance, this expression looks very lengthy, but there is actually a simple pattern hidden inside it. Look carefully at the angles. They are 3x, 5x, 7x, and 9x. All of them are equally spaced around 6x. That tells us we should pair the terms around the middle because they will produce the same angle after applying the sum to product identities. This is the key observation that makes the entire problem easy. Start with the numerator. Pair sine 7x with sine 5x. Using the identity sin a plus sine b equals 2 sine a plus b by 2 cos a minus b by 2, we get 2 sine 6x cos x. Now pair sine 9x with sine 3x. Applying the same identity again gives 2 sine 6x cos 3x. Notice that both pairs now contain the common factor sine 6x. So the numerator becomes 2 sine 6x into cos x plus cos 3x. Now simplify the remaining bracket using another identity. Cos a plus cos b equals 2 cos a plus b by 2 cos a minus b by 2. Substituting a as x and b as 3x, we get 2 cos 2x cos x. Hence, the numerator becomes 4 sine 6x cos 2x cos x. Now move to the denominator. Pair cos 7x with cos 5x. Using the identity cos a plus cos b equals 2 cos a plus b by 2 cos a minus b by 2, we get 2 cos 6x cos x. Next, pair cos 9x with cos 3x. This becomes 2 cos 6x cos 3x. Adding them together gives 2 cos 6x into cos x plus cos 3x. Once again, simplify cos x plus cos 3x as 2 cos 2x cos x. So the denominator becomes 4 cos 6x cos 2x cos x. Now divide the numerator by the denominator. The common factor 4 cancels. Cos 2x cancels. Cos x also cancels. We are left with sine 6x divided by cos 6x, which is simply tan 6x. Hence proved. The important lesson here is that whenever angles are equally spaced, always look for smart pairing instead of expanding randomly. That usually makes the proof much shorter. Now let's solve the next identity. We need to prove that sine 3x plus sine 2x minus sine x is equal to 4 sine x cos x by 2 cos 3x by 2. Once again, don't try to simplify every term individually. Instead, first combine the terms that are connected by the plus sign. Start with sine 3x plus sine 2x. Using the identity sine a plus sine b equals 2 sine a plus b by 2 cos a minus b by 2, we get 2 sine 5x by 2 cos x by 2. Now rewrite the remaining term sine x as 2 sine x by 2 cos x by 2. This is a useful trick because both expressions now contain the common factor cos x by 2. So the expression becomes 2 sine 5x by 2 cos x by 2 minus 2 sine x by 2 cos x by 2. Take 2 cos x by 2 as a common factor. We get 2 cos x by 2 into sine 5x by 2 minus sine x by 2. Now focus only on the bracket. Apply the identity sine a minus sine b equals 2 cos a plus b by 2 sine a minus b by 2. Here a is 5x by 2 and b is x by 2. So the bracket becomes 2 cos 3x by 2 sine x. Substituting this back, we get 2 cos x by 2 multiplied by 2 cos 3x by 2 multiplied by sine x. Finally, multiply the constants to get 4 sine x cos x by 2 cos 3x by 2, which is exactly the required result, hence proved. The biggest takeaway from this proof is that rewriting one term in a suitable form often creates a common factor. Once that common factor appears, the remaining expression matches a standard identity and the solution becomes very straightforward.